So you can see the hinge location here, Chris.
Yeah.
And I don't know whether you can see that in the shadow or not. That's the one that's at the top end of your sample.
Yeah.
That one there.
Yeah.
Okay. So if James puts the sash back in, that's actually located the sash. It's got no screws in it at the moment, but we can actually operate it.
Wow.
Giving the time then for the fitter to go and get his screws, get his battery screwdriver and fix the sash and make it permanent. That's unique to our system.
Very clever.
Yeah. So that applies to all three of these sashes. You can just lift them out, lift them back in again.
Yeah. One of the big things, Chris, when we looked at the system, was that the actual window fitters on site spent a lot more time glazing aluminium systems than PVC. What this effectively means is that all the glazing can be done in a controlled environment in the factory, and the actual installation time takes less than PVC.
Does that cause you a problem, Roger? Because you've got to glaze, take the responsibility for that, and you've got to ship it as well.
But lots of people, it also reduces damage, so it's quicker. The fitters actually love it because they can fit it a lot quicker. A lot of aluminium, you know, typically with aluminium, Chris, you get lots of different glazing gaskets and wedges. So the fitter will have a van full of different compressed gaskets to fit. Well, this means that all that can be done with one gasket in the factory. So when it goes out, it can be fitted.
Right. I mean, I must admit, I was wondering when I got this sample, I was surprised at how heavy it was. So it's interesting that you can actually take the whole sash out.
Yeah.
It makes a big difference then to fitting it.
And it's also, because of the clip-in sash, it's a one-man job rather than two-man job.
Yeah.
Traditionally, to lift a sash out, Chris, it would take two fitters. One to actually open the sash up.
Yeah.
Somebody would then hold the sash whilst the other person takes the screws out, and then he'd have all the weight straight away. With this system, there is no weight. It can actually take the screws out, the sash will still operate, and then last minute, it can disengage it and lift it back in again. It was a one-man job.
The action you've got from installers, because that must be a huge advantage to them.
It's a big time saving. Like Roger said, talking to installers, PVC installations against aluminium is like for like until it comes to the glazing. When they get the glazing, it normally takes about 3 times longer to glaze an aluminium system than it does PVC. Because obviously PVC, you've got beads, you knock them in with a mallet, job done. Obviously with aluminium, you've got to be very, very careful when you're beading a window that you're not going to scratch the other beads or scratch the frame. So you've got to take a lot of care over it. And then, like Roger says, quite often you'll come to it, middle of winter, everything's cold, the gaskets are cold, they're more solid, and it's harder to glaze. So obviously doing it in a controlled environment, you control the temperature as well.
Yeah.
You've basically got the time down to presumably putting in an aluminium window, not far different from putting in a PVC now.
Probably less than, because you haven't got to glaze it. You've got the glazing has gone completely for the fitter. So all he's got to do is actually install the frame.
Very big advantage then, yeah.
Yeah.
The only bit that I don't quite see how you've got round, and that is if you've got a non-opening window.
Right.
You can't get to that.
So I've got a non-opening window like this, Chris. Can you see?
Yeah.
This has now got friction stays on the side, exactly the same as an opener. And then on the bottom, we've got a dummy sash packer, which is basically a 2-part packer. Part of it screws to the main frame, part of it screws to the sash. And then when you actually hinge it and close it, they clip together and stop the window moving. So what we do on site, if we want to take all these sashes out, let's say it was a window 3 times the size, then again, we would take it off the hinges, Yeah, we would actually leave the part of the sash removed, the actual dummy sash packer off the sash, hang the window back again. Yeah, make sure everything was working and fine, and then eventually we'd screw then the dummy sash packer to the sash and then clip it home and finish the job. If we ever want to take this out again, the dummy sash packers basically are on a fixed position. There is a deglazing tool that drops in the back that releases that clip.
Right.
So what we do is we took a special tool down the back of the gasket, find that clip, release it, and then it becomes like a normal opening sash.
Right.
And also, Chris, as well, if you're making proper windows, you should always have a dummy sash anyway to keep the sight lines the same.
So as a window, Chris, that looks balanced.
Yeah.
Because it's got a dummy sash in.
Yeah.
It looks far better.
Yeah.
You don't get this big step from sash through to fixed light.
Mm-hmm.
Everything lines through.
Yeah, absolutely.
So on the inside, Chris, you're saying because there's no bead here, you can see how neat this area all looks with the handle. The handle's connected to the frame.
Have you had to get the handles specially designed to be that narrow?
No, it's a standard handle, Chris. That is, yeah, that's showing an inline. That's actually one from Total Hardware. Yeah.
Right.
So you're pulling on the frame all the time. You're not pulling on the bead.
Yes.
So that's far stronger and solid. Yeah.
Yeah.
But you're still containing
very
this
nice.
very slim sight line. Another thing we've done uniquely, Chris, obviously now you have to gasket this window up because it's beadless, and we have a wedge gasket front and back. So obviously the ideal thing is to have that gasket continuous on all four sides. So what we've done, we've developed a machine. So what it can do, it can actually punch this area out so that can be folded round the corner. So we can have a continuous gasket, and then the final corner is mitered. But this machine will obviously measure out the gasket, punch it, and it's done it as a twin now. So what we can do then is tear that in half. That becomes the outside, that becomes the inside.
Yeah.
And it obviously tucks itself around the corner.
Another problem with aluminium gaskets, Chris, is that typically fitters have to wedge them on site, and what they do is sometimes they cut the miters short, so you get the gaskets pulling away from the corners. So
Right.
it looks like a kit.
So to stop that as well, you can see here, we've done that as an anti-shrink, so you can't stretch the gasket, Chris. It's got a rigid part to it. The blue is a rigid, yeah. So you can't actually stretch the gasket.
Right.
So you don't get this creeping back from the corners.
Again, is that a special gasket, Dave?
Sorry?
Is that a special gasket?
It's a wedge gasket, but it's been developed by ourselves. Yes, it is our own product. It's not just an off-the-shelf wedge.
Right.
Yeah, we've developed it, I say, as a twin. So it's both front and back gasket in one, because obviously the front and back gasket are going to be exactly the same size, aren't they?
Yeah, absolutely.
Yeah. So obviously you cut it all as one and then tear it in half, becomes the front and the back. Let's go back, Chris, to what we were saying about competitors and how it looks with the handle on the inside. You can see this is onto the bead.
Yeah.
Yeah. So if you go up to the top corner, Dave, you can see the square cut of the bead, then the mitre.
Yeah.
Yeah. So our view of that is that. So viewed from the inside, obviously looks far, far neater, simpler. Yeah.
Yeah, very much so.
And then again with the handle, when you come down to the handle area, this is actually a moulding that's been produced to try and make the situation a little bit better, but it probably makes it aesthetically look worse because you've buttered your bead either side of this moulding, and then the actual handle is connected to the moulding. Instead of just doing standard sills completely in aluminium, you've obviously got to create some sort of thermal break. So what we've done, we've come up with this self-assembly system for the sills. So you have a thermal break centre for the sill, you have an outside edge, and you have an inside edge. And these clip together. create a sill. Beauty of that, obviously, if you've got different colours inside to outside, you're cutting down on a lot of wastage now. So you'd stock an outside in white, like we've got here, thermal break, and the inside being the squirrel grey. Yeah.
Yeah.
So normally that would be one component, and I'd have to order it as a white on grey sill. And if I was only having a metre, let's say, for one window, I would have to order 6 metres of it. The other 5 metres probably becoming scrap. So you would have to add that into the cost as well of the window. With this, you can literally cut a metre of white, a metre of your thermal break, a metre of grey for the inside, and assemble it yourself.
Neat.
One of the things, Chris, that happens normally on aluminium is what the guys do, they actually face drain all the sills, all the frames. So I don't know whether you've ever seen, but on normal situation, you'd have drain covers caps on the outside of your window on aluminium.
Right.
Well, obviously on PVC, all we do is conceal drain. So what this enables us to do is conceal drain. So what we'll do, we'll drain through the main frame here and then slot out the bottom, and then the water can run away on the face of the sill. So we don't need to put horrible drain cover caps every metre on the outside, because obviously they discolour as well and they just look awful.
Yeah.
So this is like we would with PVC, a concealed drainage system. Yeah.
Yeah.
So what can happen then is obviously with air and water driving back up through here, if it's very windy, water can blow through the back of the sill. So what we've done on the thermal break is coax the gasket onto it. Normally what you'd say to a fitter is that you would have to silicone between the sill and the frame. So if he doesn't do that, there's a big chance that water can get blown back through the sill. But if you if you coax it, you're taking all that onus away from the fitter. So he doesn't have to use any silicone. And that is a big selling point to the fitter.
So far, you haven't used silicone anywhere in this application? Not on the glazing, not on the draining, nothing?
Nope. And the same principle applies to all our bays as well. If you look at all our competitors, they recommend that you use silicone to seal all the bays. But again, what we've done, we've taken the thermal break and coax gasket on the inside and the outside here, which then butt up to the frames and create a seal. So again, even on bay windows, there's no silicone required.
I mean,
it's taking the onus away from the fitter, isn't it, Chris? At the end of the day, if he doesn't do that, one, you've got a remedial, and the worst case scenario is like if he hasn't done it on a sill, you've actually got to take the whole window out, because the only way to do it is literally take the window out, take the sill off, silicone it, and put it all back together again. So what we're trying to do is cut down on stock as well then, Chris, stock holdings. So again, the principle of the sill and the bay poles, so they're in 3 components so you can assemble them. Obviously, bring stock holding down as well for the fabricator.
I think it's worth saying that on the ancillaries, the vast majority is shared with Prestige.
Yes, it's a common component, certainly, with both systems.
Yeah.
Right.
And kind of for the different thicknesses, the kind of the Thermovic centre piece, it just changes, but you kind of use the same aluminium outers.
Yeah, so if you can see in the case here, we've got the 3 Thermovics. And that covers the whole range of the classic system and through to the Prestige.
Right.
But obviously all the nose part of the sill and the back edge of the sill stays the same.